It's a requirement of our wiring regulations that any equipment must be able to withstand the maximum current that could flow where it's installed. So for that, we need to find the prospective fault current, which is obviously known as a PFC, sometimes known as IPF. That's the maximum current that can flow. Because we need to measure the highest value that's likely to flow, we need to make sure that everything is connected and turned on, because that way at least we'll get current flowing through all of the parallel paths. That's quite important. For that, I need to use a prospective fault current tester. Our earth loop instruments normally do the same job. So for that, I'll turn it on to high current, and then I test between, first of all, I need to know prospective earth fault current, which is the maximum current that could flow between any line conductor and earth. So with 2 leads, remember this is a live test, so you must take great care at all times. I go from my earthing terminal to our L1. Earthing terminal to L1. And with this machine, I need to push a button to give me PFC. And we can see that the maximum current between earth and L1, or this is an old board, so the red phase would be 2,323 amps. I then can do the test between the yellow phase, or which would be now be known as L2. Up here, look, we can see it's indicated it's the yellow phase to earth. Take a reading, push the button, and I've got 2,071 amps, which again is very close, so that's good. Next, I go to the blue and earth, take another reading, push the button, 2,426. So roughly speaking, 2,400 amps is the highest it can flow between any line conductor and earth. Next, I need to measure between line and neutral. Again, all lines are neutrals, so I'll go on L1 first, or the red phase in this case. Take a reading, push the button, 2,593. Now between the yellow and the neutral, push the button, 2,290. And now between the blue and the neutral, push the button, 2,297. Now, because this is a 3-phase supply, obviously current that could flow between 2 phases would be much higher. And as a rough guide, which is probably as accurate a calculation as you could get, you would need to double the highest value which we had between line conductors and neutral. So if we say this is 2,300, if we double it, 4,600 would be the value that we would put down for prospective fault current. Some instruments can test between 2 lines. You need to make sure that your instrument is capable of doing that, because the current that could flow is quite high. This instrument can manage that okay, so just out of interest, we'll do a reading and we'll see what value we get. First of all, I'll go between L1 and L2, or in this case, red and yellow. And I've got 3,488. Between red and blue, 4,148, yellow and blue, 3,732. So the highest value there I could put down as quite an accurate reading for PFC, although, as you saw, the value of line to neutral doubled was slightly higher, which is always going to be on the right side. So whichever way you do it is perfectly acceptable as far as the regulations are concerned, because the value between line and neutral is always going to err on the side of safety.